Welcome to the What to Where full stack web application built using the MERN stack. At the time of recording, the front and back ends are being hosted via a Google virtual machine. The front end of this project features two pages, a home page and a profile page. Home page is seen here. Profile page is inaccessible because the user is not logged in. If that's the case, they will see the home page just like any other user, like we see here, without access to a profile page. They can sign up or log in. These features make calls to the backend where data is stored in a MongoDB database and authenticated. The home page features a call to the OpenWeather API, which takes currently hard-coded coordinates to provide weather data for that location, currently La Pastora, and a toggle switch for the desired units, Fahrenheit or Celsius. It shows the user, logged in or not, what clothing items would be suitable based on the weather. The hot, cold, or warm categories were coded depending on different temperatures. The weather API does not return those values, it simply returns the temperature, and I determined which temperature ranges are hot, cold, or warm. So 75 degrees Fahrenheit qualifies as warm, and as you can see, if I click these two cards, they both will say warm. Right. So you can sign up a user. They would have to provide their email, password, name, and a URL to an avatar. But for now, let's log in using this user. Whoops. Log in. Test30 at test.com. Test30. And voila. Now, upon logging in, it takes you straight to the user's profile page, from where the layout is a little bit different. You have another button from where you can add new clothing items. You can see all the clothing items that this user will have created, and you can click on them. Notice the presence of this delete button. This is only available to logged in users and to users who have created that item. So if I'm logged in and I go to the home page and I click peach, I'm unable to delete that item because this user did not create that item. However, if I click hoodie, I am able to delete that item, and you get a confirmation modal warning you that this action is irreversible, and I can delete the item from there and it disappears immediately from the page. Refresh and it is gone forever. Click profile, it is gone forever. Okay. So we can add a card. So we can press add close or add new. It's the same thing. Let's add the hoodie again. Let's see. Okay. And let's say it's warm and we have the hoodie. Alright. Refresh and it's saved on the database, so it stays there. You can delete the card as I demonstrated. You can also like cards so long as you are logged in. There's one problem with the like icon. It is not currently visible, but as proof that it does work, you can see that it does send a request to the server and it does show in the likes array if it's liked or disliked. If it's liked, it adds the current user to the array of likes. If it's unliked, it simply removes the user from that array. You can change the user profile data. So instead of super user, I may want to put ultra user and an avatar, and now this person is now ultra user. Refresh and it stays the same. And every user that's logged in gets their token saved to local storage which is saved in this format, and upon logging out, this token is removed from local storage. One of the challenges in creating the front end to this application was keeping track of the methods. It was sometimes difficult to get some of the API calls and other methods working because I wasn't always aware of the data type with which I was working. Sometimes the data sent or the expected data were the wrong type, which led to a tedious repetitive task of backtracing. Eventually I spent a couple hours working on a README file that stored all the data types I would be working with between the front and back ends. Alternatively, I could have documented the functions as I went, perhaps using JS docs to improve development efficiency, and of course being more experienced helps in the long run. A couple of key improvements can be made here. If I want to select different locations, I can add a feature for that. So currently all users will see data for La Pastora, but maybe they want to select different locations. More weather type options besides hot, cold, or warm can be added. The weather API currently returns highly detailed data in object form, as you can see here. And this can be used to implement more options and increase user experience accordingly. Real-time form validation using validity state can be implemented. Currently, users have to click sign up or submit whatever form before they get any feedback regarding their entered information, which can be inconvenient, especially if the form is rather long. And instead of saving the token to local storage, I can save the token and any other user data to the local system using cookies. And one fix that I have to implement is the like button not showing up properly. So that's the front end. On the back end, we have a server that works with a local MongoDB to store and validate documents as necessary, controlled by routing at various API calls defined as needed. Process Manager 2 restarts the server in the event of a crash, and nginx handles the serving of files to the subdomain and proxying. The backend features validation, which have custom exported functions, which are handled by Celebrate, which use joy schemas to validate any incoming requests. Custom error objects, like bad request error, for example, are coded to avoid hard coding any 400 HTTP errors, or 404 or 403. This way the code is more streamlined, and any custom message will just need to be provided upon this new object creation. Request and error logging using Winston is demonstrated here, and upon request, any type of request made is logged here. Any type of errors that occur during requests is made here. The challenges I faced were that many of the libraries used in this project were new, like Winston, Joy, and Celebrate, and they took some time to understand and appreciate. Understanding the need for them took some time as well. My understanding in setting up cores was shown when I tried to use the cores library and a callback function with app.use, as seen here, for setting origin headers. This would always cause an access control allow origin error whenever I tried to load up the front end of the application. All I needed to do was just use this. It isn't the most secure because it allows requests to my backend from any origin, which is a serious security issue, but for now this will have to work. At one point during testing, I couldn't figure out why my authentication middleware wasn't receiving a token from the local system, as it should, to keep a user logged in. I would always get an authorization error for that user. It turns out that the token had expired. I figured this out by noting the presence of a timestamp with each token log, and when I converted the time using an online tool to a readable date and time, It was 7 days and a few minutes into the past. My token lifespan was set to 7 days upon creation, so it made sense. All I needed to do was log out the user and log them back in. So I hope that provides a sufficient demonstration of this full stack application. Thank you.